Let's review our 5 steps of hypothesis testing again. First, we make assumptions about the possible relationships between variables after conducting a literature review. 2. Based on the literature review, state your research hypothesis. A non-directional research hypothesis is used if little information is known about the relationships between variables. A directional research hypothesis is used if we have prior knowledge about the relationships between the variables. State your null hypothesis, which states that no relationship between the variables occur. Select the alpha level, which is abbreviated with the Greek letter alpha. The alpha level indicates how big a risk the researcher is willing to take when rejecting the null hypothesis. Remember, we are always attempting to reject our null hypothesis, in contrast to supporting our research hypothesis. When selecting the alpha level, the researcher is asking, what happens when there is a difference between treatments? Was the difference just a fluke caused by sampling error? We typically select an alpha level of 0.05, meaning that the researcher is willing to erroneously reject a null hypothesis 5% of the time, or is willing to appropriately retain the null hypothesis 95% of the time. Our SPSS software usually sets the alpha level at 0.05. However, we have the option to change the alpha level. However, when the stakes are high, we might use a more conservative alpha. For example, when comparing different antipsychotic drugs, we need to be more conservative to ensure safety of those who would be receiving such drugs. Considering this example, we might use a more rigorous alpha of 0.01, meaning that the researcher is willing to erroneously reject a null hypothesis 1% of the time, or is willing to appropriately retain the null hypothesis 99% of the time. The researcher reports the alpha level using a p-value, which stands for the probability of something happening by chance. For example, if we see a p-value of 0.05, we can interpret this as findings reported would be expected to occur by chance less than 5% of the time. Here's the associated confidence levels, considering the z-scores. The distribution of values on a normal curve between two standard deviations above or below the mean is equal to 95% of the scores. In other words, 95% of the time, the values computed for the sample statistic will fall near the value of the population parameter being estimated. We can also say that 95% of the time, the value computed for the sample statistic will fall one z-score above or below the mean. A z-score of 95% for the values equals 1.96. 5% of the time, our sample statistic will lie outside the population parameter, or what is called the critical region. For example, we have 95% where we do not reject the null hypothesis, as 95% of our values will fall within this range. However, 5% or 2.5% on either side may fall in the critical range, or what we call the tails of the distribution. Researchers reject the null hypothesis when our sample statistic falls in the critical region or the tails. For example, 5% of the time our sample statistic will differ substantially from the population parameter, falling within the regions known as the tails of the distribution. Alpha level 0.05. Alpha divided by 2 equals 0.025 times 100 equals 2.5%. Unlike the two-tail hypothesis mentioned above, the distribution of a one-tail hypothesis will indicate the critical region, or 5% of the distribution, to be on one tail or the other. Considering this example, we see a positive relationship. This slide demonstrates a one-tail test with a critical region for a negative relationship. This slide demonstrates a two-tailed research hypothesis. For example, you decide to use couple therapy to decrease child abuse. Not having any literature to support how couple therapy would impact the abuse of the couple's children, you decide to use a two-tailed hypothesis. It's important to remember that normal distributions are greatly influenced by the sample size, with distributions of low sample size appearing flat and more spread out. Distributions of low sample size also increases our sample error. Also, remember the following. that between group differences must be extreme to reject the null hypothesis. Use one-tailed test of significance to increase the chance of being able to reject the null hypothesis. If you use one tail and get results that are an opposite tail, you cannot call the results statistically significant. Here's a helpful table to assist you in determining the sample size that you would need in order to obtain a specified critical region for a one-tailed test and a two-tailed test. This concludes the PowerPoint on estimation, hypothesis testing, and statistical significance. It's really important that you understand these concepts, as the following instructions and calculations will require you to interpret p-values. If you have any questions, please reread your textbook and share your questions on Ask the Professor.